Hello, everyone. This is Stanford's team. Basically, our team is Sultan Al Harbi.
Juan Chong.
Thomas Noble.
So, this is the mission statement for Stanford University, which says, fueled by optimism, ingenuity, and a sense of responsibility, we seek to accelerate our purposeful impact in the world. And this is also their guiding principles. So they want to renew their commitment to Stanford's founding purpose to promote public welfare by exercising influence on behalf of humanity, anchor our efforts in integrity, ethics, inclusion, and human welfare, advance our mission as a research university to serve as a place of enlightenment and freedom of thought and expression. So moving to the backgrounds of Stanford University. Stanford University was founded in 1885 by California senator called Leland Stanford and his wife Jane Lathrop. Stanford University was opened then in 1891. Stanford University has about 16,500 students. About 7,000 of them are undergraduate and 9,537 are graduates. Stanford University has 2,219 faculty members. Their main campus is located in Palo Alto, California, and their new campus is located in Redwood City, California. They have 7 schools and 76 academic departments. They have business, education, law, earth, energy, and environmental sciences, humanities and sciences, engineering, and medicine.
Okay, so some of the potential activities and work products. Our main goal or our main job is to be consultants. Our job is to advise Stanford from a point of view of an industrial engineering student or intern. We are here to apply like certain methods that we have learned, like Excel, Minitab, QM, and ProModel. Performance implications and consequences. So if we are successful implicating this project, we're able to save the university money, help them properly staff the new campus, and help them maintain building standards. Alternatively, if we fail or do not succeed, we will underutilize the workforce and have poor building maintenance.
So one of the things that took everyone globally by surprise was this pandemic of COVID-19. And it's definitely played a part in how we communicate as a team and how we communicate with our partners in Stanford. Our weekly meetings were put on hold, but we've been able to resume them via Zoom, and all of our future correspondence going forward is going to be held through this platform. Stanford's been an excellent partner and has been continuing to have their doors open to us virtually and provide as much information and structure as could reasonably be expected. Our group did have one in-person meeting towards the beginning of the pandemic, but we've since moved our communications to Zoom in accordance with state and local mandates. So some of the activities that we've been engaging in, we analyzed the floor plans along with our partners at Stanford and identified a floor that we could put into our ProModel simulation. We've gathered the human factors data on relevant allowances, and we obtained work scope for both janitors and for technicians. We've gathered and organized the work orders, we've reviewed the historical data sets, and we've obtained equipment lists that we're using to create a PM calendar. We're currently in the process of presenting those intermediate findings, and Stanford will help us course correct if that becomes necessary.
In order to help us find data and information to put into our simulation, here's an example of the daily janitorial duties. The daily janitorial duties are basically what a janitor has to do every single day or whatever specified on that day. Some examples are taking out the trash, like cleaning up the trash can, clean up the doorways, the vacuuming, stuff like that. So this will give us an average time of janitors' time being used and being utilized. And to help us to refine this data, we use some human factors like time study, basic body motion using MSD, and also by shadowing Sandy, which is a custodian that works there, is one of their best ones, or one of the ones they want as a standard for Stanford's janitorial services. Another method is method time measurement, which a table on the picture here shows how to calculate movement and how long it should take to finish and complete a job. Here's an example of the time study is empty out a trash can. So it gives I try to list as much motion as possible. And using that motion is given a number, a data, which is then multiplied by the frequency of how much time is used, and that equals to the TMU. And TMU can be all added up from every movement and given for that specific job how long it took or will take them to do. And here's a flow chart of a work order. So previously discussed was stuff they have to do before the day even starts. So it's already on their agenda, but the work orders are a variable. It could be more or less one day. And this just shows the process of how the work orders come in and how they handle it. So here's an example of daily work orders. So it comes in from, so you have a complaint, you file it, and then it comes into the call center, and then the call center decides what's priority to send out and what to fulfill during that day.
So choosing the simulation floor. Before we choose the simulation floor, we got together and came up with 3 questions that we asked Stanford. So the first question was, what floor has as much number of small machines? Second question was, which floor is relatively fully occupied by employee? Because those buildings are new, so some of these floors are not like fully occupied by employee. So we wanted to make sure that our simulation is done on a floor that is relatively fully occupied. The third question we came up with, also, which floor has the work of porters lead, tech, and tech lead? And their answer basically was Cardinal Hall, 5th floor. So then we started collecting data for our simulation. As you can see in the table, for the small machines, we have microwave, refrigerator, toaster, dishwasher, coffee maker, oven, sink, and water heater. And their units. For the large machines, we have 2 units of chillers and 1 compressor. And also we have asked Stanford about the floor plan of the Cardinal Hall 5th floor with the dimensions, so we can use in the Pro model. We asked them also their PM calendar, so we can figure out the distributions for each machine. Also, we asked for the custodial scope of work, which Juan talked about earlier. So this is their current simulation simulation layout. Basically, if we go to the kitchen, there are 3 trash cans, 2 refrigerator, 1 microwave, 1 oven, and 1 toaster. If we move to the restrooms, they have 4 restrooms, and each restroom has 2 sinks and 1 hand dryer. And also as you can see in the layout, we have 4 cleaning spots. So it was a little bit challenging to get the utilization of the porter because all they do is cleaning. So what we did is, and we wanted to show that on the simulation, like the porter himself or herself is moving around. So what we did is we asked Stanford about the total time that it takes the porter to clean the whole floor. We divided this number by 4, and then we put 4 locations on the layout. And also there is this little room here. It's actually on the roof, which has the larger machines. So as we said, we have 2 chillers and 1 compressor. This is still not a complete version of our simulation. It's still missing data that Stanford is still on the process of providing us the remainder of it. They are a little bit busy with their emergency shutdown process, so we are being patient.
So once we do have all that data and Sultan has compiled everything into his simulation, what we're going to do is we're going to have that feed into our Excel workbook and provide this with a usable tool that allows the user to designate the space they're looking to model. Based on those pro model results, it'll actually calculate the productivity for these people, which will be in terms of utilization, and the number of unresolved issues will be presented per day. The Excel workbook as it stands right now, on the left-hand side, you'll see I guess that may be the right-hand side depending on how you're looking at it, but the calendar, which has Monday, Tuesday, Wednesday, and a 5-week rolling average, will actually pull from the other side of the screen. It's just used for janitorial at this point, but we will be inputting the preventative maintenance for the technicians as well, and that'll actually feed through at the cadence that they have requested. The final page to the Excel workbook is how we're calculating our RM and PM, which is reactive maintenance and preventative maintenance. And as I said, we're going to feed all of this information in here once we've got frequency data for both RM and PM, and for each one of those positions through the scope of work. That'll feed into the cleanliness equation for janitorial staff and a PM equation for the technician staff. Our Gantt chart seems like we're actually pretty much on track. We defined the problem, we set goals and responsibilities, we started our written report and presentation. We may be a little bit behind on the written report, but I think our presentation is coming along nicely. The human factors data has been gathered, and we've input a great number of it into the Pro Model simulation, as well as the Excel workbook. We're currently in the process right now of combining our efforts so that we can review those initial results and revise our strategy. From an integration standpoint, Juan is going to compare the proposed human factors data that we hypothetically had and his time studies that he's been able to carry out at the Stanford campus. We won't be able to conduct any more time studies, but we have the data that we can compare and contrast and implement into the model. Sultan will then take that those notes and combine that into his Pro Model simulation revision, and that'll feed into the Excel workbook update that will be able to help us complete our presentation. At that point, we'll be able to complete our written report and present our findings to the class. Our Gantt chart inputs, really happy that I found this Gantt chart that feeds into Excel because I was able to just create this this table here that automatically populates the Excel version. So as we go through the % done on that right-hand side, I'm just going to update that on the way out. As you can see, the start written report and presentation, I've only got the number at a 10% right now because that's what we as a group feel that we're at right now. But that's where we are, and we hope to have more on our next oral presentation.